All right, so today's lesson is going to be over ratios and rates in tables and graphs. We've already kind of started talking about using the graphs to be able to solve our rates and ratios problems. We're going to just kind of extend that a little bit into using a graph. Graphs are not new. I know you use them in science. When you're graphing your information, you've used the graphs before. Previously in school. So this is actually, I kind of like using the ratios, tables and graphs, especially when I want to see a pattern. All right, so here are my steps. Okay, my steps are pretty important. This is how I'm going to go about writing a table and a graph using a word problem. So my word problem for this is, for every toy ball Nathan buys, he buys 2 free tickets, or he gets 2 free tickets. Here is my word problem. That's all I need to know in order to fill out a table and a graph. All I know, all they give me is that for every toy ball Nathan buys, he gets 2 free stickers. From that information, I'm going to write a ratio, okay? I'm going to be comparing balls and stickers, yes? I know that for every 1 ball, he gets 2 stickers. That is the information that I know. I now just wrote a ratio. 1 ball to every 2 stickers, or every 2 stickers for every ball, okay? Now I'm going to make a table. The very first part of my table is always my labels. So I always got to make sure that I start with my labels on my table. Now, from that, I'm going to fill in. I know that there's 1 ball is going to give me 2 stickers. That is what I know, correct? Now, I can go ahead. Now it says, I'm going to make a table. So if that's all they give me, the rest of my table, it doesn't matter what numbers you put in. Okay? I may go straight down and go, okay, for 2 balls, 3 balls, 4 balls, 5 balls. Maybe you want to go 1, 3, 6, 9, 12, whatever. It doesn't matter because it's still going to be equivalent. Okay? So for the purposes of mine, I'm just going to go straight down and say, okay, I know 1 ball is 2 stickers. So 2 balls will be how many stickers?
4.
3 balls will be?
6.
4 balls?
8.
5 balls?
10.
Everybody with me on that?
Mm-hmm.
Okay, so far so good. All right, so I've made my table, right, with my labels, what I know, and then I filled out the rest of the table. Now I'm going to list my ordered pairs. Now, who remembers what an ordered pair is? Anybody remember what an ordered pair is? It's not up on my word wall. That's what I was checking. It's not up there. I guess I got to add some stuff, huh? So an ordered pair is when I have my X value, my Y value. Now that should ring a bell because you have done ordered pairs before, right? Whenever you're doing graphs, you go X and then Y and then you push your dot, right? All right, so now to decide which ones are going to be my X and which one's going to be my Y. So if my first one will always be my X, my second one is going to be my Y. We also call these inputs and outputs. And I'm going to write that over here just so that I remember. Let's see, am I going to cut that side off? Nope. All right, so X is my input, Y is my output. So if I input 2 balls, I'm going to get 4 stickers. If I input 3 balls, I'm going to get 6 stickers. Okay?
We did this last year.
I know, y'all did the input-output tables last year.
We forgot to put the rules times 2.
We haven't gotten there yet.
Oh.
We haven't gotten to the rule yet. So now I'm going to go ahead and I'm going to list my ordered pairs. exactly how I have it. This is going to be a 1, comma 2, a 2, comma 4, 3, that's my X value, Y is my, or 6 is my Y. Number of balls, 4, number of stickers, 8. Number of balls, 5, then I'm going to get 10 stickers. Those are my ordered pairs. All right, so it says graph the ordered pairs and connect the points. We'll get to that in just a second. Let's go back over here to my rule, okay? My rule. That is asking me what is happening. So I'm going to do this here. My rule is what is happening to my X to get to Y? That's the question you're going to ask yourself. What am I doing to X to get to Y? What am I doing to the balls to get to stickers? What am I doing? I heard times 2. We got to make sure that it works every time. So 1 times 2, does it give me 2?
Yes.
Does 2 times 2 give me 4?
Yes.
And 3 times 2, does it give me 6?
Yes.
4 times 2, does it give me 8?
Yes.
5 times 2 gives me 10?
Yes.
So my rule is multiplying by 2. All right. Now let's go to graphing this. This is easy. So here is my coordinate plane. That's what this little thing is called. All right. And we have, this is my nice, I don't have a dark one. I'll use this one. I know you learned all about this last year, right? Now, there's a couple of things that I want to make sure, because I will count off if this is not done right. I must label my X and my Y's, okay? So my X's and my Y. What does my X represent? Balls or stickers? Balls, so I'm gonna label this balls. And what does my Y represent? Stickers. All right. Now I am going to go and I'm going to make sure I have labeled my intervals, which are the lines. Okay. Now, my intervals, that's what they're called. My intervals can be anything that I want. I could count by 5s. I can do it by 10s. I can do it by 1s. I can even do it by halves. Okay? So I'm going to look at my balls here. And I know it's going to go up by 1, right? So I might as well make my numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So before I can go to graphing this, I need to make sure that I have labels and my intervals are labeled. Now for stickers, I can do one of two things. So when I look over here at stickers, I've got 2, 4, 6, 8, 10. I can go by 2s. I can also go by 1s, okay? And I can decide either one. I know that my largest number is going to be 10, right? So I don't need to go by 5s or anything because I'm not going to have enough room. So I'm just going to go ahead and do this one by 1s also. So my intervals on my X and my Y can be different. All right, now let's go ahead and label. Now let's go ahead and plot. Plot. So I've got my first one is where X is 1. I'm going to go to the right 1, and then I'm going to go up 2. 1, 2. My second one, I'm going to go to the right 2. 1, 2, and then up 4. 1, 2, 3, 4. Oh, right 3, up 6. 1, 2, 3, 4, 5, 6. Right 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right 5, up 10. Does everybody see that I plotted? I had the same number of plots that I do ordered pairs. And now it says to connect the points. That's the easy one. Connect the dots. La la la. Connect the dots. La la la. Alright. So, it's pretty easy doing the table, right? And the graph. I like connecting the dots. I like the ones where we make pictures. Alright, let's look at a new scenario here. So, new ratio. If Nathan receives 40 stickers, how many balls did he purchase? Okay. So now we're using the same scenario for every toy ball Nathan buys, he gets 2 free stickers. Now it says, hey, look, he has 40 stickers. How many balls did he purchase? So this is where we're going to set up our proportion. I have my labels, but I'm going to go ahead and make sure I have labels here.
You just divided by 2 since you already know the rules too.
Nope, we are going to set up a proportion. What I know is that for every ball, he's going to do 2 stickers. And we don't know how many balls, but we do know that he has 40 stickers. Right? Does everybody understand? So my proportion looks like this. And then I can just go ahead and cross multiply and divide, and I'm going to get what? 20 what? If I needed to, could I have gone up here and written a 40 right here under stickers? Yeah? Awesome. All right, flip it over. All right. It says Rachel is riding a train to her aunt's house. The train travels at a constant rate of 55 miles per hour. Which table represents the relationship between H, the number of hours Rachel travels, and D, the distance she travels over a certain length of time? Woo! All right, so we know that the rate is 55 miles per hour. Yes? And we have our variable of an H, which represents the number of hours. And we have D, which is the distance. So far, so good? Yes? Now, I'm going to tell you the way that I would probably solve this. But you can choose to use that. You can choose not to use it. So what I would do is I'm going to cover up the answer choices for right now. Because sometimes the answer choices seem reasonable and I choose it and just move on. But I want to go ahead and I want to pretend like the tables are not there and I'm going to make my own table. Okay? So I'm going to say, okay, I've got my table and I'm comparing hours and distance. Those are my variables. I know that it's 55 miles for every hour, correct? Yes? All right, so if I traveled 2 hours, how much would it be? 110. And what about 3 hours? How far would I go? 165. So that is my table, right? Now I'm going to look at my answer choices and find which answer choice fits that. 1 is 55, so that works. Well, this one is going to be a no. That one's a no. That one works, okay? I said at 3, it's going to be 165. That's what I said too, okay? Here it says 4 is 110. Well, I already said that 2 was 110, right? So that's a no. So that leaves me with A. All right, let's look at this next question. A brownie recipe requires 4 cups of sugars and 3 tablespoons of vanilla. If the recipe is reduced, which proportion can be used to find the number of tablespoons of vanilla, tablespoons of vanilla needed if 1.5 cups of sugar is used? Okay, so I'm going to take baby steps on this to make sure that I don't just choose. So what am I comparing here? I've got 4 cups of sugar, 3 tablespoons of vanilla. So I've got sugar and vanilla. Then I'm going to move on, and I know that my rate it gives me is 4 cups of sugar to 3 of vanilla. What is it that I'm looking for? 1.5 cups of sugar, and we don't know how many vanilla. All right, so let's look through my answer choices and eliminate which ones I know for sure. A, would that be a yes or a no? For sure.
No.
That's an absolutely no, right? I don't compare 4 over 4 and V over 1.5. That's not going to help me. All right, definitely not B. So now I have 3 over 4 is equal to V over 1.5. Well, that doesn't look like the one that I have here, but I'm going to put a question mark. It doesn't look like it, but I don't know. I'm just going to put a question mark and I'll move on. So I look here at the next one. 2/3 or 2 to 3 is equal to V to 1.5. Well, there's nowhere there's a 2, so that's going to eliminate. Now let's talk about C for a minute. Is it in the exact same order?
Yes.
No, this one is written V over sugar, right? Does V over V to sugar going to give me the same stuff as sugar to V?
Yes.
Yeah, so there we go. Just because it doesn't look exactly like that, I have to see, okay, well, what were they comparing? I compared sugar to vanilla, but in the answer choice, they compared vanilla to sugar, okay? Because ultimately, when I solve it, I would do 3 times 1.5. Here, are they going to be multiplying the same 2 numbers?
Yes.
Yeah. So that's how I know that that proportion is the same. All right. Last but not least, to make purple paint, Tia mixes 8 cups of blue paint to every 5 cups of red paint. Which table shows the possible values of R, the number of cups of red paint Tia uses, and B, the number of cups of blue paint? All right, same thing that we did with number 1, because I don't want to get mixed up. I'm going to make my own. And I know I'm comparing blue paint to red paint. And I know that I have 8 cups of blue for every 5 cups of red. All right. So if I doubled the blue, I would get 16, which would give me what? 10. All right. What about if I tripled it? 24. Okay, so let me see. I've got just mine just thrown together real quick. Let's see if I have any of these. All right. Blue to red, 8 to 5. Well, no, that one's already wrong, right? They've got that one mixed up. Red and blue, and I said it's 8 cups of blue. All right. So we've got 8 to 5 here, blue and red, 16 to 10. All right, that one's looking good. I didn't go all the way to 20, so I'll come back to it if I need to. Blue and red, 8 to 5, 5 to 8. Well, no, that marks that one off. I've got 8 to 5, 16 to 10. Uh-oh. So I've got these 2 check marks, right? So far, they're looking good. So I wouldn't be able just to choose B and move on, right? Because D's looking like it might happen too, right? All right, so let's go ahead. And let's go ahead because we have 20, right? So 20, if I move this out to 20, it's going to be 32 over 20, yes? All right, that's going to work. And that's going to work. Well, Miss Armstrong, what's the difference in these two?
Ooh.
What do you got?
So, it's going from 4 to 5, but it missed. So on the B, it has the 3, and on D, it doesn't have 3. But on 64, that's times 8, and then 5 times 8 is.
Very good. So these are all right, and these are all right, correct? But if I were to take 8 to get to 64, what am I going to multiply it by?
8.
And whatever I do to the top, I got to do to the bottom, right? Is 8 times 5 25?
No.
All right. But I have to make sure that I check every single answer, correct? Because had I not, and I went, oh, D's right also, I'm just going to, Miss Armstrong, there's 2 answers. But there's not, because I have to check every single one, right? So the correct answer is B. Yes? All right, I want you're going to cut the bottom off, and you're going to glue this into your journal, and then I'm going to give you some work to work on.